Alright, on to question number 40. And it says, in the figure below, ABCD is a trapezoid, and the E lies on the line AD. And I'll just draw this for you so you know what I'm talking about. So it says trapezoid that looks like this. I'll draw it big so it's easy to see all the angles. Oh, let me redraw that. It's like this. So a straight line going across. And this line goes all the way across. And this is labeled A, B, C, D, and E. Right over here. And it says this angle is this angle right here. So 105. I'll do this in a different color so it's easier to see. This angle right here is 105. 105. Angle A is 60 degrees. Oh, and there is this line, diagonal line going straight from B to D, and it's a straight line. And okay, so an angle B or CBD right here is equal to 30 degrees. And it wants to know what is angle CDB right here, this angle. And I like these questions because they're sort of just like a puzzle. You have to use the laws of geometry to figure out all the angles, and eventually we'll be able to solve for this. So since the question says that point D lies on the line A to D, so this is all just one straight line. It may not look like it, but it's one straight line that goes all the way across. So we know that this is 105 degrees. We can tell that right here, this whole thing, since it's a line, will be 180 degrees. That'll be 180 degrees. So we can see that because this whole thing is 180 and this is 105, that this right here, it might be a little difficult to see, right here will be 180 degrees minus 100 or 105 degrees. So this whole angle in blue right here will be 75 degrees. 75 degrees. So now, but that's not what the question was asking for. It was asking for the angle right in here. So we have this whole angle, but we just need to figure out this one. So it would help if we knew what this angle was, angle BDA, right here. Because then we could subtract 75 from this, and that'll give us this remaining piece. So it's one key thing you need to know is that in trapezoids, they're always, the base and the height are always parallel to each other. So these line AD is parallel with line BC. I forget what the notation for that is, but these are parallel. BC is parallel, I think that's it, to AD. So that means we can use the transverse line theorem, which says that when we have two sets of parallel lines, any line that intersects them will create equal angles. So this, like for instance, if we have this line going across and this line going across, if we have a line that just cuts them in half, it'll create equal corresponding angles. So in other words, this angle right here will be equal to this angle right here will be equal to this angle, and you can just keep going on. This angle right here will be equal to this angle right there will be equal to there. So we can take that and apply it to this bigger picture right here. We see that this top line is like this line, B to C is like here, A to D is right here, and this is this transverse line. So since the 30 degrees is right here, 30 degrees is right there, we can assume, or we know that this will also be 30 degrees. This piece right here, angle BDA will be equal to 30 degrees. And since that's equal to 30 degrees, we can do 75 minus 30 degrees is equal to 45 degrees. Right? Because since this angle right here will equal this angle, and this angle is equal to this angle by the vertical angle theorem, then we can just use that and apply it to this bigger picture and solve, and we got 45 degrees. Okay, we'll go on to question number 41, and it's another picture. Let me just erase this. Fill in the background, and we'll go with blue. And alright, I just skipped ahead so you didn't have to watch me draw this out. And it says, question 41 says, in the figure shown below, each pair of intersecting line segments meets at a right angle. So that means all these angles are right angles. All these angles are right angles. I won't draw it for all, but you can see. Each pair of intersecting lines meets at a right angle, and all the lengths are given in inches. What is the perimeter in inches of this entire figure? And this 6, maybe I should draw it a little closer. It goes for this line, not this one. This 6 is for down here. The 4 is for this line. 10 is for up here. And 26 is for this whole thing. So we can see that we don't have this side length, and we don't have this side length, and we don't have this side length. But we'll be able to figure this out. So one thing we can tell is that we are given the entire height, not the width, just these heights of this left side. So the entire height, we could say the entire height of this shape will be equal to 4 plus 6 plus 4, 14. And we know that the bottom, the entire bottom, we're not sure what these values are, but the entire, we're not sure what this one is either, but the entire bottom will be equal to 26 because it's given. So we know that, and since all these are right angles, we know that this is going to be a straight line going across. So this height on this side will have to be equal to the height on this side. So this height will also be equal to 14. And so using the same reasoning, we can tell that the width going along the bottom will be the same as the width going along the top. Try and squeeze this in here. Width along the bottom is the same as the width along the top. And so we don't really need to know these side lengths. We just need to know the total of the entire side. So since this is equal to 14, we would be adding x plus x anyways to get to, maybe this should be y because they're different lengths, but we would be adding x plus y to get to this 14 anyway. So we don't necessarily even need to know these values, we just need to know the total value. So we have 14 plus 14, which is equal to 28, plus 26 plus 26, which is equal to 52. 52 plus 28 will be equal to 80. So the entire length of this shape, the perimeter, will be equal to 80. And that's the answer. So we'll go on to question 42, and I should be able to squeeze it in the bottom here. 42. 42 says, of the 804 graduating seniors in a certain high school, approximately 2/5 are going to college, and approximately 1/4 of those going to college are going to a state university. Which of the following is the closest estimate for how many of the graduating seniors are going to a state university? So it says there are 804 graduating seniors in the entire class. So this is the total amount, 804 students total. And then it says approximately 2/5 are going to college. So out of all of these students, only 2/5 are going to, or out of all these students that are graduating, only 2/5 are actually going to college. So we can quickly solve for that to see how many are actually going to college. So 2/5 times 804, because that'll give us the number of students actually going to college. 2/5 times 804, 2/5 times 804 is equal to about 321.6 students. So you have to be careful because 320 is an answer choice, but it says of the students going to college, approximately 1/4 are going to a state university. So out of these students going to college, these are going to college, 1/4 of them will be going to a state university. So we can multiply that by 1/4, 321.6 times 1/4 is equal to 80.4 students that are going to a state university. So even though these we have 321 students going to a actual college, out of those students only 1/4 or 80.4 students are going to a state. And the answer for that one is 80. Well, just 80 because it says approximately. And that's the answer. I'll see you in the next video.